So, good morning, everyone. My name is Katie Lebeds from Learning to Lean. I'm here with you this morning to talk about FEMA, Failure Modes Effects Analysis. So, let's go ahead and get started. If you don't know who I am a Lean Six Sigma Master Black Belt and Certified Project Management Professional. I own a lean consulting firm called Learning to Lean, and I'm based out of Hortonville, Wisconsin. I am also an author. I've written 3 books and that are available on Amazon. And I have over 20 years experience in project management, continuous improvement, leadership, and coaching. And I'm so honored to be able to be with you here today. So thanks for joining me to talk about a very interesting topic. So when we talk about FEMA, so failure modes effects analysis, we're really talking about risk analysis, and risk management. So sometimes people look at this and go, "Oh, we don't want to talk about risk. We don't want to be negative." No, that's not what this is about. This is not about being positive or negative. This is about being realistic because we know Murphy's Law. Anything that can go wrong will go wrong. So we are trying to get ahead of it in doing a FEMA. And this is an opportunity for us to really gather together as a team and brainstorm how we can try to eliminate any possibility for mistakes or errors and reduce the risk. Now, every company that we work with, right, has a different risk tolerance, right? So some companies are very risk averse. And traditionally, those type of companies, just to name some off the top of my head, would be like an insurance company, right? Insurance companies are more risk averse. They have people that are doing all the statistics to be able to understand all that risk. So they're maybe on the one end of the spectrum where we'd say they are risk averse or really not as tolerant for risk as maybe another company would be, right? So some companies are not risk averse, they're risk accepting, which is perfectly fine. But you have to understand what the tolerance is within your organization and your company and what level of risk that you are willing to take on. So when we're talking about risk, we're talking about anything that can or will go wrong. So that's what we mean by risk. It's a negative impact to another person or process as a result of your project or what you're working on or what you're making or the service you're delivering, or it's also considered an unintended consequence. So we look at risk. We talk more about risk in project management. In any of our belt training, we go through risk in detail, and we really talk about, how can we brainstorm and figure out how to identify those risks. So with risk, we're really looking at 3 aspects of it. So we want to identify risk, we want to acknowledge risk, and we want to work to eliminate risk. So if you are familiar with the story about the Ford Pinto, there's a great video on YouTube about the Ford Pinto. It's called Pinto Madness, and it talks about risk. And it's a great video I show in all of my classes, though I'm not quite sure how much longer I'll be able to show that video because people won't know what I'm talking about. But Ford recognized in the design of the Pinto that there was, as they say in the video, a deadly engineering flaw, which it really was. And if you're not familiar with the Ford Pinto that started production in the 80s, it was a engineering flaw that if you were rear-ended in that car, it could explode. So it was an exploding gas tank. So they did a risk analysis and they determined that it was cheaper for them to take on the lawsuits than it was for them to fix the car. So they had many people that had passed away from obviously being in a car like that. They had 117 lawsuits. So that was a case of risk. They identified it and they acknowledged it, and they didn't work to eliminate it. They just accepted that risk. And that's a company's decision, and it has to do with the company, the leadership, and the culture. So as we look at risk, and somebody said to me, how does risk line up with Lean Six Sigma methodology? Well, it lines right up with the DMAIC methodology, or in project management, your project management, if you follow PMI methodology. So in the define phase of a DMAIC project, which stands for define, measure, analyze, improve, and control, and then define phase, we're really understanding what problem we're trying to solve. And in turn, we're also identifying risk. In the measure phase, we're gathering our data. And for risks, we're looking at the impact of those risks, the probability, the occurrence, and consequences. In the analyze phase, this is where we're making sense out of our data in a DMAIC. In our risk view of this, this is where we use FMEA to prioritize risks from most to least. And then in the improve phase is where we get to make changes to our process for a DMAIC. And for risk, it's risk mitigation. And we create that mitigation plan, which we'll talk about today. And you create it and implement it. And then in the control phase of DMAIC, this is where we make sure that our process and our changes stick and we get our desired results. Under risk, we're looking at the success of a plan. It's monitored and the current risks are reassessed. And new risks are identified because risk happens all the time, right? Everything is alive. So, and we're going to talk about looking at FMEA and how that's a living document too. So, let's just take a look at what is FMEA. So again, failure modes effects analysis. I'm going to talk to you about the two different kinds of FMEA. It helps us to identify and prioritize and eliminate known or unknown at this time potential failures of a system, design, or manufacturing process before they reach the customer, right? So that's the key word there, is that we want to do this before it reaches the customer. You can do a FMEA again for a process. You can do a FMEA for a design. This doesn't mean necessarily that you can only do a FMEA in a manufacturing environment. That's absolutely not true. You can do this in a service environment too. You think about the process to get a operating room ready for a procedure, the process to be able to do blood draws. I just had one done the other day. So we can look at it from that aspect. We can look at it from an IT system also. So again, it's talked about mostly in manufacturing, but this is also outside of manufacturing too. Our goal is to eliminate the failure mode, which is something bad that can happen, and reduce the risk, right? And it's a living document. So you're going to hear me say that multiple times today. It's a living document that reflects the latest design, product, and process actions. So once you create a FMEA, it has to be updated. If you are in an industry that you are subject to audit, for certifications, internal audits, they are going to look at this document. So once it's there, it's there. It helps us prevent problems rather than reacting. You're trying to head it off at the pass. That's what a FMEA is really all about. It determines, how bad these effects are. So we determine something that bad could happen, but really how bad is it, right? Is it horribly bad where somebody could perish? Or are we talking about a minor inconvenience? And we'll look at an example for an ATM, which is a funny example that I like to show. Probably not funny if you work in banking, but identifies the controls. It helps us to be able to quantify and prioritize the risks, which is great, especially if you have a product or process that has many risks and you're like, gosh, where do I start with this? And the FMEA form that we'll look at allows you to do a mathematical calculation to figure out what you should focus on first. And it gives us also a plan of action. So that's fantastic. So again, our FMEA, so failure modes effects analysis, is to identify and mitigate risk. So recognizing and evaluating the potential failure, predicting the highest risk, right? Assessing the effect on all customers, so internal and external. And we don't always think about that, right? We think about, oh, what bad thing could happen to our external customer, or we're really going to lose market share, or they're going to be, really upset, or they're going to lose trust in our brand. We also have to think of our internal customers. Again, it's a business risk tool. And we prioritize risks, which we'll look at on the form, using an RPN, risk priority number. So here's two acronyms together. Risk priority number is created by SOD, severity times occurrence times detection. right? So if all RPNs are equal, so we do all the calculation, and I'll show you in a minute, severity times occurrence times detection, you're like, gosh, I have all the same numbers. The risk with the highest or higher severity wins. That's the one we should work on first. So that's how you prioritize it. So again, two acronyms in the same sentence. RPN, risk priority number, is calculated by SOD, severity times occurrence times detection. We'll look at that in a second. So benefits. Yes, there are benefits to doing this. It assesses the effects on all the customers, right? It helps you to evaluate requirements and alternatives. It allows us to be able to look at, some other possibilities. Again, it gives us that prioritized list. So it's not just a laundry list, it is a list of what we should focus on first. And everybody wants that, right? It's like trying to figure out, I have to clean my house. Where should I focus on first? What's my priority, right? Helping to validate your intended design. Some customers, again, require this. Depending on your industry, if you are making a medical product, you are probably going to have to do this. I have customers with wide variety of industries that must do this. This is a requirement from their customers, so you can't get away with it, away with not doing it. And then it allows us to document results of design, manufacturing, or assembly process changes too. So every time you change something in the design or manufacturing or assembly or service provided, you have to update your FMEA. So again, living document. So again, some customers require a FMEA. So you have to know that, and you have to make sure that you are following that. I have customers that this is required from their customers, right? And they will not get any business if they don't do this and keep it up. So they're subject to audit from their external customers. So there's two different kinds I mentioned earlier. There is a DFMEA and a PFMEA. So what's a DFMEA? A DFMEA is a design FMEA. So this focuses on analyzing and improving the reliability and safety of your new design. Now, it could be new to you, or it could be new to your customer, right? It's just new. So whether this is the first time you're making it or you are creating it, because the old adage of I gave you a sketch on a napkin and now you've come up with a design to make this wonderful thing, that's when we would use a DFMEA. So it looks at design deficiencies and it focuses on interactions and product features. So it's a proactive approach to design thinking. So as we're making this thing, providing the service, we're thinking of how all these different things could go wrong, right? These two parts might not fit together. This may leak, it's things like that. And I'll talk to you here in a moment of what we should prioritize first. So again, helps us to identify process or potential failure modes early, and it allows us to improve safety. PFMEA, which stands for Process Failure Modes Effects Analysis, is a proactive approach to identifying potential process failures early in the process planning cycle. So looking at this before, right? We have the design is done. So if you have to do both, you're going to do a design FMEA and a process FMEA. So our design is done and it's ready to go. Now we're figuring out what risks do we have associated with actually making this product or delivering that service. It assists in development of process control charts, and it's going to be your documentation for the reason behind process changes. Now, keep in mind, if this is required by our customer, if you've done a PFMEA and you make a change to the process 6 months from now, because you did a Kaizen event and you're like, this is going to really improve the process, you have to update the FMEA again, your PFMEA again. And many times you have to do another evaluation or proof of concept for your customer. So it's quite in depth. So let's look at it in a table format. So process FMEA used to identify and analyze risk for every step in a process. So from doing step 1 through step 10, you're going to be looking and saying, okay, when we machine that part, when we deliver those units, when we move it from place to place, when it comes out of the welding robot, you're going to look at each step in that process and what could go wrong. If it comes out of the robot and the weld is wrong, what do? Right? Do we just grind it down or do we stop the process? It gets to the end of the process and it doesn't work. We plug it into test and it doesn't work. Then what do? Right? Design FEMA is used to analyze when we're designing a new product, right? So that's cool. It's like design for Six Sigma. So design for Six Sigma is saying, hey, how are we proactively approaching this in order to eliminate the possibility for errors? PFEMA, again, uncovers how a process can fail, requires process flow diagrams, so we have to know each step in the process. It's performed at that process level, and the key characteristic is the input. DFEMA uncovers how a product can fail and its intended purpose. And that's really important to understand its intended purpose. So what is this intended to do? Right? So I'll give you an example, right? I've brewmate like these cups. What's the intended purpose for this, right? So the intended purpose is to keep cold things cold or hot things hot. And then you go from there, right? Is it intended to go in the microwave? No, it's not. It won't even fit in the microwave, but they make smaller ones, right? So we look at that and go, what's this intended use for this? Its intended use is to, again, hot or cold and allow me to drink out of it. And the cool part about these is that I can move the switch and it won't leak. So that's what I like about those. So technical specifications, I'm sure it would have technical specifications in regards to that thing I just moved. Performed at a system or product level, and key characteristics are the output. So DFEMA, again, going back to DFEMA for just a second, let's focus on that. Again, looking at design for Six Sigma. And so DFEMA really is looking at how are we integrating this into the design? So are we designing for cost or manufacturing or testing or reliability or security or agility or compliance, et cetera? So when we look at DFEMA, the outputs are a potential list of failures ranked by RPN, so risk priority number, list of critical or significant characteristics. And many times your customer is going to tell you that, right? Your customer is going to tell you what is critical to quality characteristics. And that's where you start with your DFEMA because it's overwhelming. And you're like, I don't even know where to start. This is just, it seems like a mess and I'm overwhelmed. Start with the critical to quality characteristics that you get from your customer. They're the ones that are going to tell you on a print, this is a critical dimension, this is a critical area, etc. DFEMA is also going to get you a list of parameters for testing and recommended actions, right? So we're just not making a crab list of here's all the things that could go wrong, good luck, right? We also have to come up with the actions for it. So again, the benefits, like we said, establishing a priority for design improvements. So it's not just a list of these things could go wrong. It's a list of these things could go wrong and this is what we need to focus on first, and some rationale for changes. Because we all know that some people are just like, oh, it would make this better. And you're like, just a minute, let's do an analysis on this. Again, it allows us some information for design and validation or verification testing, critical to characteristics, helps us to identify and eliminate potential safety concerns, right? Isn't that fantastic? We really wish that they would have done a better job on that on the Ford Pinto. Helps us to identify product failure early in producing or the development phase. And shorter development times, of course, and lower productivity, development, and warranty costs. So the concept, though, is that you're probably looking like, wow, that's a lot. It sure is, right? However, we can use the output, right, of a DFEMA if we are building or creating something new or similar or based off of that, like version 2 of the product, right? So this will live on and we should be using it for historical purposes and references also. It's like, don't forget, we don't want to use that or that type of material wasn't great. We probably shouldn't use that. We've used that cleaning agent and we know that it can disintegrate the plastic. We can't use that. It's all things like that that we want to be able to leverage as lessons learned for the future, right? So that's D FEMA, so design FEMA. This is process FEMA, so P FEMA. So the purpose is, again, these are both team approaches. So to resolve issues or concerns and problems in the process that results in a low quality being shipped potentially to the customer or delivered to the customer internally or externally, right? So it's conducted before the first production run occurs, right? So in the world of manufacturing, if you were doing a production run, that means we're live, right? So that's what that means. We're doing a production run. So that means for all intents and purposes, everything is as it should be. We've done this portion, we've done our PFEMA, maybe even a DFEMA if you were responsible for design, right? And now we have everything identified, we've mitigated, we have our plans in place, we believe we know our value stream map, right? We are good to go. So this is done way before we say, yes, flip the switch, we're ready to go in production. And of course, the goal is a defect-free product. Now remember, we want to deliver a quality product. We don't want to inspect quality in. What does that mean? That means we want a repeatable process with predictable results. So we don't want a product that has to be inspected every single day, every single time we make it, right? We want to know that we have a repeatable process that gives us good results, right? Inspecting quality in is not going to get you a quality product. If you don't know, the statistic is 100% inspection yields only 80% results. That means you still have 20% escapes or bad things delivered to your customer. And if you're like me, you probably aren't willing to allow that. So goals for PFEMA, right? Identify risk, as we've already talked, and reduce reliability of the process. We want to make sure that we are identifying risks that could have a bad impact on your quality, your reliability, customer dissatisfaction, safety, environmental. So that's what we're looking at. So we're looking at hazards derived from man, method, materials, machine, measurement, and Mother Nature. Those are the bones on a fishbone diagram. So we use brainstorming tools during a FEMA, either DFEMA or PFEMA, to brainstorm where the risks come from. Of course, our goal is the production of an end item that meets or exceeds the safety and quality characteristics of the design documentation. So what are the benefits? We've identified the risks, right? We conceptually will not be delivering a quote unquote bad product or service to our customers. It gives us that ranking, and you may be thinking, gosh, why is that so important? Because you could have hundreds of items on that list and you just don't know where to start. And by doing that risk priority number, it allows us to figure out where to start. Again, it gives you documentation of the fact that you've done this and that you've worked through all those processes. It gives the team an opportunity to do root cause analysis. And, that can be challenging, right? Because we figure out, oh, we're just building one of these, it's just a different size. No, it's not always like that, right? Let's do some root cause analysis and let's eliminate the possible risks, right? Allows us to identify critical characteristics and operator safety concerns, right? And then feeds the information. And conceptually, we should be able to go back to design and say, you know what, this is creating a problem for us. It would be great if we could change this. And if you worked in manufacturing or areas where you're just like, they create these things, but they have never been on the production floor to understand how it comes together. That's what we're talking about here. We want to be able to provide that feedback. And as you can imagine, this is a continuous loop, right? We have this continuous loop of we're trying to improve the process, but here's a risk associated with the design. Go back to the design team and say, hey, can we make any adjustments? Can we maybe choose a different material? Can we do this in a different process, etc.? So it is supposed to be a team effort and it's supposed to be cohesive and collaborative. So how does this work? So now you know what a DFEMA is and a PFEMA. These are the overall steps. So we review the design process. We brainstorm potential failure modes. Now, how do we brainstorm? We brainstorm using an affinity diagram, a fishbone diagram, a mind map, right? Use one of those tools because that ignites the creativity in people instead of like, all right, let's write down all the bad things that could happen. Let's get creative. Also, if you're doing a brainstorming session, make sure that prior to all of this, you've identified who's on the team, right? And you've told them, hey, next Tuesday, we're going to do a brainstorming session on the risks associated with this design or the risks associated with this process. So you do have to identify and form the team, right? And then you can review the design or the process, start brainstorming using one of the brainstorming tools. Then you start to list the potential effects of the failure and assign the severity. And I'll show you an example here in a second. Then you can list the possible causes, right? So what causes these bad things to happen? And assign the occurrence. So the occurrence is how likely is it to occur? The severity is how bad is it? Then we can look under and see if we have any current controls to keep this process or this design to keep it from behaving or misbehaving itself, right? And assign the detection rating. And detection means how easy or hard is it for us to find this problem? Are we going to know right away that this bad thing has happened? Or is it, as you can imagine, buried somewhere in the depths of a car that we would never find, right? Until there was something very bad that went wrong. Then we calculate our RPN, our severity times occurrence times detection, and that gives us a number. And then we prioritize those based on that number. So highest number goes first, except if all RPNs are equal, the one with the highest severity goes first. Then we develop an action plan and take action, and then go back through and recalculate the RPN and do periodical reviews and start again. So again, continuous cycle. This is not one and done. It is a living document. So where do we start? If you are working with your customer, which I hope you are, you start with your critical to quality characteristics. So these are the critical to quality characteristics are the measurable items that we would have on a drawing, or as you can see here, this is a nice dining experience. The critical to quality was the number of people, the table sitting, the starters, how many starters, appetizers, main items and desserts they offered, the chef experience, the pricing, the special menu, waiting time, etc. So if you are in manufacturing, you know what the critical to quality characteristics are, or your customers told you. They're very critical to quality, usually specifications on a print that's going to tell you, this spec or the tolerance. Generally for the critical to quality ones are pretty tight. So a high level overview for looking at this from a FEMA perspective. You look at systems hierarchy items and functions, and then look at failure modes. From failure modes, we look at the effects. So what bad things does it cause? And then there's your severity times occurrence times detection. And then we look at prevention controls and detection controls, and then actions. So just another way to look at it. So what does this look like? Of course, if you haven't already guessed, it's a form, right? So failure modes effects analysis form. It's a pretty standard form unless your company has companyatized it, right? It's a pretty standard form. So on the left first column, we have the functions. What functions or features or requirements are we looking at? And then the potential failure mode, which means what could go wrong. And then potential failure effects. So what are the effects of the bad thing that's gone wrong? And then we assign the severity. So that's the S. And I'll give you some numbers just as a suggestion here in a second. And then we look at potential causes. So what caused this bad thing to happen? And then we then rate the occurrence. So how likely is it to occur? Is this like 1 in a million chance? Or 1 in 10? Okay. Current controls, so what do we have in place to prevent and detect them? And then we put in our detection rating. So detection means how easy or how hard is it to figure that this thing went wrong. So let me give you an example. My husband loves Hilti tools, and he has a chuck on his drill that is not working right. So not an old school chuck like they used to use the key, right? This is the one that you just hand tighten. And he was telling a friend of ours, there's something wrong with the chuck. And, he uses the tool all the time. So he just got a new chuck, and we were talking as I was coming home, and he was saying that now he knows what's wrong with the chuck. There's a screw inside of there because he was Googling how to replace this chuck. And the screw head obviously got sheared off at some point. So when you look at that and go, how hard is it to detect? He had to take apart the drill before he could figure out that that screw head had been sheared off. So detection in that case is really difficult. I would give it like a 10 because there's no way you'd know that unless you took it all apart. Then you calculate your RPN or risk priority number, and then you have to have your recommended actions, and those have to be documented there. What are the actions? What are you taking? Or are you accepting the risk? And that's something that you can do as an organization. Now, of course, this should be discussed with the leadership team in your organization and the appropriate people. Recommended action, you could document there that you are accepting the risk, and that's a company decision. Responsibility and target completion date, and then actions like taken, and then saw it all over again. So that's what it looks like. When we're looking at ranking, this is unique to you, your products, and your customers. So if we're looking at severity, so that's that first table on the left-hand side, when we're looking at severity, this came from a failure modes and effects analysis book that you can rate it. You should have some verbiage around your ranking, right? So rating here for severity, again, this is just out of a textbook. They're saying 1, if we have it at a 1, it's no effect noticed by the customers, the failure. The customers will never know, basically is what they're saying. The customers will never know. And a 10, that if we rate something on a 10 for severity, we're saying there's a hazard with no warning. So that means it's the worst thing that could possibly happen, right? You could be just driving, and we've heard of all these recalls with cars, right? Hazard with no warning. You could be driving and you have no brakes, or you could be driving and you have no steering, right? So there would be a hazard with no warning. That would be a 10. Now, occurrence, again, rating of 1 to 10. Remote occurrence, so again, you need some numbers in regards to this. So you'd have to know if the failure is unlikely, like statistically speaking. So that's rated 1 to 10 there. And then detection, so rating of 1, design control will certainly detect, so that's easy to detect is a 1. So we'll be able to see it right away, right? Or a 10, which means there's no controls in place. We have absolutely no idea if it happens. So again, that's just a suggestion. These are just textbooks. You can certainly change them from there. You should document in your FEMA your rating, and then some tables like this that explains the logic behind your ratings, right? And don't keep changing them. So don't say, oh, for this one, we're going to do 1 to 5. And then the next one, we'll do 1 to 10 there, you need to have some sort of standardization, and you need to know that as a company as a whole, right? So then you have to document your acceptable risk levels, just like we were talking about when we first started. Some companies are risk avoidant, and some companies are risk accepting. So what numbers here are you like, we're still good to go, right? We're going to accept that risk, or, oh, absolutely not. We're not doing that. If the number's higher than a 3, no, we won't do it. So you need to know that. You have to have those discussions. And then you should document your assumptions. So again, as you've heard me say multiple times, FEMA is a living document. So what kind of assumptions, we all know what assumptions mean, right? So what kind of assumptions are we talking about? Raw materials are all within spec. That could be an assumption. You need to document that is your assumption. Right, wrong, or indifferent, unless you have data to prove otherwise. Document that raw materials are all in spec. Again, these are sample assumptions. We're assuming the product will be manufactured or assembled within engineering specs. Maybe that's another assumption that you're making. Does the team wish to consider an exception, such as part design may include a deficiency that could cause unacceptable variation in manufacturing or assembling process? Is that an assumption that you're making? What are the assumed environmental conditions, right? If you live here in Wisconsin and you are doing anything outside, those environmental conditions can be very different, right? So what are we assuming the environmental conditions are? Uh, are we assuming product abuse by the customer, right? Are we assuming product abuse by the customer? Right? Product abuses could be how many times have I knocked this off? How many times have I dropped my cell phone? Right? There are definitely certain things that you expect product abuse from. What's the definition of failure? That's a good assumption to have documented. What do we assume is failure? Are we all in the same place? And what is the process the team will take to obtain approval for FEMA recommended actions and follow up? So, who is that final say so there? And who's going to document it, right? Everybody's going to go like this, not it, not it, right? Nobody wants to document it. But there are tools that we can use and we can turn AI on and have those things safely in a paid subscription help you document it. And who's going to keep track of it? So let's look at an example. This is a banking example for an ATM. Now, some of this you'll look at and go, wow, this has to be, the world's worst luck. But it could happen. So let's just look at an example. So the function is, as we know, an ATM dispenses the amount of cash required by the customer. So fair enough, we all understand that. What bad things could happen? Well, doesn't dispense cash. Yeah, that's true. What else could happen? It dispenses too much cash. Now, who gets that luck that you get too much cash when you go to the ATM? Or takes too long to dispense the cash? Okay, and this example came from asq.org. So we'll just go with those three. So what's the potential effects of the failure if it doesn't give us the cash, right? Customers very dissatisfied. Yeah, I would agree with that. Incorrect entry into the demand deposit system. Yes, that's true. And discrepancy in cash balancing. So this creates a ripple effect. So we have an upset customer and then all of our books are off. If it dispenses too much cash, obviously the bank loses money and we have another discrepancy with our books. And takes too long, the customer, I love this one, the customer is somewhat annoyed. Yes. Now, personally, if I go to the ATM and it takes too long, I just assume that it ate my card. So when we look at severity, they're saying doesn't dispense cash. They gave it an 8 out of 10. So pretty severe. Dispenses too much cash. Interestingly enough, to give it a 6. And takes too long to give it a 3, which I'd agree with. What's the potential cause of not dispensing cash? Well, it's out of money, right? Out of cash. Machine jams, sure, or power failure during the transaction. What luck could you have if you went to the ATM and lost power? Dispenses too much cash, bills stuck together. I can definitely see that, and denominations in wrong trays. So I don't know about you, but the ATMs that we go to, they'll only dispense 20s. So that is a poke-yoke or mistake proofing that the banks have done, at least around here, is that the ATMs only dispense 20s. So they don't have to worry about somebody putting the wrong denomination in the wrong tray. Next, heavy computer traffic for taking too long to dispense the cash. That's possible. Or, gosh, another power interruption, another power outage. So, potential causes of the failure, how likely are they to occur? Out of cash, they gave it a 5. So, I would want some data supporting that, right? So, tell me how often that happens. Machine jams, they gave it a 3. Power failure, they gave it a 2. I guess it happens every once in a great while. Bills stuck together, they gave it a 2. So, that was interesting. Denominations in wrong tray, they gave it a 3. Obviously here, taking too long, they gave heavy network traffic a 7. So I thought that was kind of interesting. Might need an upgrade there. And power interruption, they gave it another 2. So what are the current process controls to keep these bad things from happening? So not dispensing cash, they have a low cash alert, which that's fantastic. They also have an internal jam alert, and they have no sort of controls for power outage. Well, if the power's out, how are they going to know, right? Dispensing too much cash, they have a loading procedure. So that's good. And they have a 2-person visual verification. So that's good too. Taking too long to dispense, they have no controls. So their severity, they did their severity, the occurrence, and detection now. For low cache alert, they gave it a 5. Internal jam, they gave it a 10. And not having a current control for process or power failure, they give it a 10. Too much cache loading procedure, they gave it a 7, easier to detect or harder to detect. If I would prefer that they had their little index on the side or legend to tell me what their numbers meant. Two-person verification, they gave it a 4, and taking too long, they gave those both 10. So now you can see that they gave their RPN numbers, they did their calculations, so severity times occurrence times detection. And the one that they would focus on first, obviously, is right here. So not dispensing cash because they have a machine jam. Now, they also gave an internal criticality calculation. So they did that on their own. That is optional. So they did a criticality. So how critical is this for their organization? So that's a simple example of FEMA, right? Easy to understand from a banking perspective. And again, the one thing is obviously they have to complete it, and it would be nice to have a legend so I know where their severity and occurrence and detection numbers are coming from. So again, you've already heard me say this multiple times. It's a living document which should be updated anytime the design or the process changes. So it's not all doom and gloom, right? It's risk-based thinking. So risk-based thinking can improve customer confidence and satisfaction. It helps us to ensure consistency of quality goods and services and establishes a proactive culture of prevention and improvement, and to have successful companies intuitively take risk-based approach. So it's not all bad, right? It's just about understanding and acknowledging and accepting risk or doing something about it. So how can I document risks without a FEMA? Because maybe you're thinking, gosh, Katie, I manage projects or I'm not in manufacturing. I know there's risk. I think it's important to document it, but there's no way I can do a FEMA. Well, in project management, we do something called a risk register. So a risk register, very, very similar to FEMA. But for every project that I've ever run or any project that somebody that has worked for me has run, they create automatically, if we have a new project, we create a risk register. Again, it's the same concept as FEMA, what can or will go wrong. So we have the risk description and the impact. And this time we only have the impact level and probability. So simple calculation. So this one, they gave us a little legend. They rated it 1 was low and 5 was high. And then they did a priority level. So they just did impact times probability to give them priority. And then that's what they are focusing on. They'll have their mitigation notes and the owner. So this is a light version, super light, that we would use in project management to document risks. So that should be something in every project that you work on, whether it's a Lean Six Sigma, DMAIC, or DMADV, or if you're following PMI methodology, or anything that you're following, even Agile, right? We want to identify and document and understand our risks. So Thomas Edison said, I haven't failed. I found 10,000 ways that don't work. So it's not a failure, right? It's learning along the way. And risk is a portion of our lives every day at work and at home. So we have more free classes coming up. And just to remind you that we do have online white belt training that should take you a little less than 2 hours. You can do that online for $50. Upcoming free training. So we have next month, we will learn about the Blitz, DMAIC, and DMADV from Lean and Six Sigma. And then in December, we're going to talk about an important topic that I'm very passionate about, is creating a lean culture. And then we'll start back up in 2026 with more free offerings. So if you are interested in finding what classes we have available, you can contact us directly, or you can scan the QR code to find our classes on our website. And I want to thank you for your time today. So I'd love to connect with you via email or on LinkedIn. Please reach out if you have any questions. We are constantly offering training opportunities for Lean, Six Sigma, project management, things like FEMA. We go into great detail with a full day class for PFEMA or DFEMA, and we work with you to help you realize revolutionary results. So thanks for coming today and have a great day. Don't forget to check out our YouTube channel.